Hi, this is a video on 2D triangle problems. It's our second one. This one focusing on top-down problems involving bearings. So where we're looking down as if we had a bird's eye view. Learning intentions are to understand how to convert a true bearing to a cardinal or reduced bearing and vice versa. To understand how to draw a top-down 2D diagram involving bearings, and to understand how to solve 2D triangle problems from the diagram that we just created. So first we're going to have a look at this because this is really necessary knowledge that you can't do the rest of these without. So we'll look at that first. So bearings first of all. Here we've got our compass points, north, south, east and west. And there's two ways that we could be given a bearing. We could have a true bearing, that's sometimes called a three-figure bearing, which is given like this, with a value between 0 and 360. And it has this T afterwards, means true. So what this means, 274, means that as measured from north, that's here, and starting north and going clockwise, now you can just sort of count the angles off as we go around. Now that's 90 degrees, 180 degrees, 270 degrees, and a bit more would be 274. I'll put a line in now. There we go. So if we're starting here and going to here, from this place at the centre to this place over here, we would be travelling on a bearing of 274 degrees. That's 274 degrees all the way around. Now there's a couple of other ways that we could say this, and one of them is in this reduced bearing format. Generally we either start at north or south, whichever is closest. You can see this line is closest to north. So we would be north and then travelling so many degrees in a westerly direction, so towards the west here. For that we need to know what this is. But luckily we do, because this is a circle, it's 360 degrees. So we've got here is, if we do 360 minus that 274, we'll get a distance of what, 86. So this here is going to be 86 degrees, meaning we could write 274 degrees true in another way, which is start at north and then go 86 degrees west. It is correct still. You could, so for instance, start at west and go, just see if you can work out what that angle would be while I'm doing it there. We could start at west and go towards north, and it would be 4 degrees. 4 degrees north. But this is not terribly common, really. We generally go from north or south. So all the examples we've got over here on the right hand side, you can see, are involving north and south to start off with. Okay, so this is a true bearing, this is your reduced bearing or cardinal bearing, and that's how you get between the two that way. We could be given south 21 degrees west and have to work out what that is as a true bearing. So I'll just clear those off. If we had south 21 west, that means I'm starting south and going 21 degrees towards the west. Now it doesn't have to be measured accurate, but generally it should be on the right side of 45 degrees. That would cut that 90 degree angle in half, so 21 degrees, this will be fine here. That means that's 21 degrees there, so I've started south and gone 21 degrees west like that. So to work that out as a true bearing, remember true bearings start at north and go all the way around. So it shouldn't take too much to see that, well, we've got 90, 180 to there, plus our 21 gives us 201 degrees. Okay, so what I'd like you to do now, have a look at this right hand side set of questions here, try and work those out, and pause the video. I'll come back in a couple of minutes and check and see if we agree. Okay, there we are. So you can check your answers against them. If you find you got any wrong, I would just pause the video, go back a bit, try them again, see if you can work out where you went wrong before you move on to the next bit. Okay, now the next part here, this is a bearing type top-down 2D question. We have a ship sailing 3.5 kilometres on a bearing of north 25 degrees east before changing its bearing, sailing on a different direction for 4.2, find the distance from its starting point. So, first thing we have to do here, draw a diagram. I'm going to have a starting point here. Now, I can safely go over to the left because I'm going to go northeast and then northeast again. So, it's going to be up and right and up and right. I can tell that from here. Now, north 25 east, the very first thing I should do is stick in some compass points like this. And you'll see why it's useful, even if it's a bit of a pain, you'll see why it's useful to do this for all for all the points that we use in a little while. So that's north. We don't really need to write, providing you know the others are east, southwest, you should be okay with just labelling north. Then north 25 east, that's north, and then I go 25 degrees this way. Gives me, let's use blue for the path of this ship. So 25, so something like that. And as we go, fill in everything that we know, 25 degrees. Okay, he gets to a certain point here, that's after he's travelled for 3.5 kilometres. And then changes his bearing and goes north 70 east. Now I'm going to put in another set of compass points here. You'll see why in a second. So you can just mark these on in pencil on your diagrams. And he goes north 70 east, so 70, remember this is 90 degrees, so that's going to come most of the way over, but not quite all the way over. And this is 4.2, so I should draw a slightly longer line, but we're not measuring here, it's not super accurate, just a little bit longer would be about that. And what we know first off is that that is then 70 degrees. And it says find the distance from its starting point, so we actually want to find out what this distance is there. That's where we also know he's travelled 4.2 kilometres. That's 4.2 there, and that's 3.5 there. Okay, so have a look at that for a second, pause the video, see if you can work that out now, and then I'll go through a method for solving this in a second. Okay, so what we've got here is the same method we used in a previous video on 2D problems, and what you should start off by doing is draw a diagram, then add everything that you know. Well, we've done that so far. Identify the part you have to find, and then see if you can spot a useful stepping stone, then work out the stepping stone to find the final answer. Now this is the tricky bit, of course, because it means that you have to try and work out something or figure out a way to get to the final answer that's not necessarily direct. With these types of problems, you can't always find the answer straight away, and that's okay. Providing you do the first bit, it makes it easier to do this next step there, step 4. So this is what we're trying to find. Let's just call that X. And then say, well, we know this side, we know that side. What would be useful? What would be our stepping stone here? And there are lots of different ways usually that you can solve these problems. But one thing that strikes me is that if I knew this angle here, all the way around the inside of that, if I knew that angle, then I could use the cosine rule to work it out, because I would have the 3 sides and the opposite angle there. So I would be able to use the cosine rule. So the question is, can we work that out from what we know? So let's have a look. can we work out our stepping stone? In fact, if you haven't already done so, pause the video and see if you can work it out now. Okay, so if we just add in some more things we know here, we know that that is a 90-degree angle. This is why I got you to add in these lines, even if it seemed a little bit much at the time. I also know, because this is 90 degrees, and we know that that's 70, that this little bit here must be 20 degrees. So I've got 20 and 90. And now this one may not be obvious straight away, but this is one of those alternate or Z angles, because these lines here are parallel, and we create this Z here. These alternate angles are the same, so that is 25. That's a little difficult to see. So what we need to do now is to pull this information out and draw a new diagram to solve the problem with. So our triangle now is like this. We have 3.5, 4.2, our unknown length that we're trying to find, and if we add up all of those angles we get, what have we got? 20, 90 and 25, so 135 degrees. Now, you can use the cosine rule to solve this. If you don't know how to use the cosine rule, that should be addressed in a different video. So try it now, pause the video, try and solve it and work out what x is, and then check in a minute. Okay, now I've started by putting in the cosine rule here. I've then changed the values for the things that I know. So x here is my a, that's the one I'm looking for. 135, that's better. 135 there is the angle, which is a here, and b and c are my other sides. It doesn't matter which way around I substitute those in there. Now I just thought, rather than work it all out, we'd stop and check, because this is a good point to use your calculator. So we could have 3.5 squared plus 4.2 squared minus 2 times 3.5 times 4.2 times, just bring the keyboard up, we're going to have cos of 135. Click on trig, cos 135. And there we go, we get a value of 50 point so now you generally use 4 decimal places while you're working out, so 6, 7, 8, 9, we wouldn't need to round up. And most important thing you recognise here is that this is x squared. The most common mistake that people make with this is leaving it, or not even writing this in, just writing x equals and then that value of 50.6789. So we need to take the square root of that in order to find x. So it's going to be the square root of 50.6789. So over here, I can drag that down, bring my keyboard up again. Oh, sorry. There we go. Oh. There we go. So square root of that, and it's 7.1189, or 7.12 to 2 decimal places. Which makes sense when we look at our question. It's the longest side opposite the largest angle, so it's going to be longer than 3.5 and it's going to be longer than 4.2, and we've got 7.12 kilometers. Okay, we're a bit short on time now, so what I'm going to ask you to do is to try and solve this as best you can, and then pause the video and come back and check. Okay, so what we've got here, we've done the draw the diagram and the write in everything you know. Look carefully at where those angles came from. Most common mistake would probably be to put those on the inside of the triangles. I've put a few more things in now. We know this is 200, this is 45 because this is 45, this is 70 because that's 20. There's my stepping stone, there's my stepping stone, and there's my final answer. Okay, that's it.